We started this project by choosing a function from the biomimicry taxonomy to explore. We were initially interested in filtering liquids, specifically water. From there, we identified several contexts to which this function could be applied and decided to create a device that would enhance human health and recreation. We wanted to design a compact, portable filter that would make creek or river water drinkable for campers. We knew that fish gills were powerful filters, so we chose them as the natural model to emulate in our own design. Fish gills consist of two structures which are oriented along the gill arch. The gill rakers are bony projections which trap larger debris as water flows through the fish gills. The rakers protect the more delicate gill filaments, which are on the opposite side of the gill arch and are used for gas exchange. Any debris not collected by the rakers is trapped in the fish's mucus. We replicated these features by adding 3 layers to our filter. The first layer is the gill raker layer and is composed of hard plastic protrusions positioned close together. The second layer is the filament layer and mimics the feathery structure of actual gill filaments, not for the purpose of gas exchange, but to filter out finer debris. Finally, we added a mesh layer which acts as the mucus and catches any other particles in the water that have not yet been removed.
Our first prototype was made out of cardboard, glue, and string. We had 3 circular layers, with the biggest one on top and 2 smaller ones underneath that could fit inside of each other, creating a collapsible design. Each layer had a piece of cardboard that stated the material we had hoped to use in the layers. They were charcoal, mesh, and cotton balls. The layers were all attached with a string, however, we were quick to notice our flaws. If we wanted to have it filter water, we would need a design that would not have as much space between the layers, preventing water loss. In addition, we noticed that besides the layers, the design did not emulate the design of fish gills, or really any biomimetic design.
Our second design had 3D printed parts that were designed by Hea and Grace. They designed 3 layers, which are now all connected. However, this design was bulky and did not collapse. It was large compared to what we were aiming for. However, this time the layers replicated the gills more. The gill rakers were replicated using toothpicks, which would filter out larger particles and act as a comb-like structure. The filaments were made of pipe cleaners to filter out smaller particles. And finally, we added a mesh layer to filter out the smallest materials found in the water.
Our third prototype came really close to what we were envisioning. We refined the design to make it collapsible with all the parts able to slide into each other for easy storage. We also added a string at the top so that the filter could be hung from a tree branch during use. And when not in use, that same string helps keep everything together. Instead of toothpicks, we 3D printed rod-like structures attached to the largest top layer to act as gill rakers. For the second layer, the gill filaments, we used tightly packed nylon bristles, the one you'd find in straw cleaners. We ordered a pack from Amazon and cut them to size to fit our filter. The third layer remained a mesh for fine filtration. Looking back on this version, there were still a few things that didn't sit quite right. The printed rods on the top layer didn't seem very effective at filtering out larger debris, and overall the design felt a bit too small to handle a large amount of water or hold too much debris.
We also realized that we had intended for our final design to be much larger than the third prototype was. So for this design, we scaled the prototype up by a factor of 2 and streamlined the gill raker inserts. Previously, the gill rakers were printed individually and had to be glued to the inside of the first layer. They were also not dimensioned or shaped in a way that would minimize the amount of debris passing through the layer. We had to emulate the shape of the natural gill rakers more closely by altering the shape of the projections used in our own design. We gave our gill rakers a long, cone-like base which tapered into a teardrop shape at the end. The length of these projections was approximately the radius of the first layer. We then used circular patterning to arrange these rakers around the inside of a thin ring. This ring was designed to slide easily into the first layer of the filter after the subsequent 2 layers had already been assembled and inserted. This allowed the first layer of our filter to have increased structural integrity while maintaining the collapsible design we were aiming for. The second layer of our final design was very similar to that of our third prototype, with the nylon bristle filaments arranged in a more tightly packed way. The third layer and the rope attachment were produced in the same way as they had been before.
Our electronics component was a photoresistor that tested how much light was passed through the water before and after the water was filtered. When the water is dirty and contaminated, not too much light will pass through, so the red light will be lit up. After it has been filtered, there should be more light passing through, so the light should ideally be green. If the water could still be cleaned more, the yellow light might light up. As you can see, when we tested the filter, the light was red when we shined the flashlight through the dirty water, indicating that it was contaminated. After the water went through the filter, it looked cleaner, and when we shined a flashlight through it, the photoresistor detected more light, and the green light on the Arduino turned on, indicating it received more light than it did before. Our filter was successful.